For this particular video, I'm going to explain to you the operations you're going to need to do to the experimental data that you're going to receive. So basically you're going to have to do theoretical forces. Those will be explained in another video, but you're also going to have to interpret the data that's given and do some operations to it so that you have the correct force value. So what do I mean here? So basically what you have in the experiment, you have a pivot point here, you have the vane which is attached to the shaft that is on that pivot point, and then on the other end of that shaft there is a load cell. So effectively you have a pivot on the end, you have a the vane in the middle, and you have the load cell there. Basically you have it's effectively a lever, right? So what you're given is the force from this load cell, which we're going to call force gauge. Okay, so the gauge force is given to you, all right? And it's important to know where your lengths are for all this. So basically what we're going to do is a sum of moments. So sum of moments around the pivot here is obviously 0. This is a static situation. So effectively you have the gauge force and you have the vane, right? So the gauge is pulling down, vane is pushing up. So we'll call up positive. So we have F vane times 6 inches minus F gauge times 15 inches is 0. Okay, we rearrange the equation to put F vane and F gauge on opposite sides of the equal sign. So you have F vane times 6 equals F gauge times 15 inches, okay? So then you divide by 6 for each side. So F vane equals F gauge times 15 over 6, which reduces to F gauge times 5 over 2. So basically all of the F gauge data that you're going to be given, you have to multiply by 5 over 2 in order to get what it is actually, what's actually being received at the vane in, more or less the middle of this shaft on this pivot. Okay, so that's important to know. You'll have to do that operation for each, the cup and the flat vanes.